tell you today about our journey, into dark hell of continuous integration and our way to get back to the surface of the earth. So very quickly about me, I started coding in the kindergarten, so I'm not yet 60 years old, just I started earlier. I happen to be on the belief in agile very quickly. I have been coaching agile and practicing agile for 10 years right now. I've been always a nerd, a tech leader, an agile coach, and recently PHB. You know what PHB is? Probably you know, point to her boss, right? So I'm CEO of the company now, exceeding 40 people, and for 6 years I've been cooperating with Atlassian as a partner, developing their core products, including JIRA. How many people know about JIRA? Cool, okay, so blame me for all the bugs, but also thank me for all the features, or most of them. Okay, so actually the other guy from Poland, the only other guy, Paweł, stole 2 slides from me, the most important, the opening and the closing one. But I will nevertheless, I'll just ask you, what's the foundation of XP is, the extreme programming, the promise which made it so attractive? Anyone can shoot out? What was the promise? The promise about the cost of change. Yes, so the traditional waterfall development meant exponential growth of the cost of the change in time, whereas XP promise was flat. I mean, an initial investment, bigger than that. So if we happen to finish maybe in the middle of this graph, it's not necessarily beneficial, but the more time we put into the project, the more beneficial XP becomes. So now let's remember about this promise, and I will come back to it at the very end of the presentation to see whether this promise really stood out in our case, because we believe that we have been doing most of the stuff, if not everything, according to XP for a longer time. So first, let me look back at what situation we were at 1.5 years ago. So at that time, JIRA codebase, which I'll be referring to mostly JIRA as the project which I have been working for last 6 years. JIRA at that time, 1.5 years ago, had about 10 years of accumulated automatic tests, unit tests, functional tests, performance tests, what's not. All of them were automatic, all of them were run. We arrived at about 20,000 tests just in the core product. If you count up all the tests of all the libraries which were Atlassian, built by Atlassian and compiled together, packaged together into JIRA, that would be easily 3 times more than that. So a lot of tests. And despite of throwing a huge, a very good hardware, we had at that year and a half ago, we had 64 servers running in a farm. All of them were multi-core, managed by a single Bamboo instance where it was just dedicated for JIRA team. And this server, despite of such hardware, 64 machines working all the time, building and compiling and running tests, our feedback loop was slow, and the quality was also not good. So we were waiting hours. These stats here are just for unit tests. So for unit tests, we were waiting 50 minutes, 1 hour, 2 hours to really so long to see the results, green or red, for our 20,000 or so tests. And the average rate of the builds which passed was about 42%, which meant red became something natural, because situation were red. Just in 42% we had green light, and it was getting lower and lower. So it meant that really our red state became a natural one, and developers started to accepting this fact that red build is something normal. Because in 58% of time, it was normal, right? So we found out that there is a huge correlation between the speed of tests, or feedback speed in this case, and the test quality. So the better tests, the faster tests are, the faster we get the feedback, the more we care about them really, the more time we spend to fix any problems, to make them again green, and the tests become better and better, less flaky, more repeatable, more stable. And the more time we invest in tests, the more time we invest into their quality, then they become faster because they are more crafted, better, and this feedback loop can go either in the right direction, but in our case, it apparently went in the wrong direction, meaning that the tests were slower and slower, the quality was worse and worse, and the tests were slower and slower, and so on. So we concluded that, okay, we have to change something, and the tests actually is just a normal code, which have to have all the due diligence of developers around design, refactoring, reviewing, discussion, maintenance, pruning, so removing unimportant tests and so on. And one of the other things we learned actually is this test pyramid, which with the arrival of Selenium, and especially Selenium 2 WebDriver, it was more and more tempting to write functional tests driven by a web browser. It was very easy to write them, especially when we started writing page objects, which were wrapping the logic of the page. So we actually created a DSL-like language in Java, which was very, very easy to write stuff like, for example, page.login, .go to issue navigator, .create issue, .assert something, right? But the problem is that such tests are very, very slow to run, because all of the communication goes via web browser, we have to wait for page rendering and so on. So in fact, we learned that this pyramid, in terms of the value, and the higher value we are, the higher we are on the pyramid, the more valuable things are, the highest value we get from unit tests, really, including QUnit tests, because the more JavaScript we have been adding, obviously, QUnit start playing more and more important role. So actually, I would say that now we are striving at about 85, 90, even 5% of tests as lower level as possible. So unit tests, either it is JUnit, QUnit, PHP unit, whatever. I mean, we don't use PHP, but it's obviously useful. Then, going back to normal pyramid, then like remaining 10% would be ideally driven by REST, which is much faster than via web browser, or where possible, we are even like screen scrapping HTML, still using, for example, stuff like HTML unit, not web browser, not JavaScript, and only remaining 2-3% tests are real Selenium, because they are the slowest. And we concluded that a year and a half ago that we really have to find an optimum balance between test isolation. You know, all of us know that tests should be fully isolated, so the running of the single test shouldn't impact the others. In practice, it wasn't as simple, because setting up a test and then dismantling it, putting it down, was costly. Could easily take, say, 5 seconds. 5 seconds, you may wonder, why 5 seconds? Times 20,000, okay? Then 5 seconds times 20,000 means a lot. So test isolation was something we have to really compromise sometimes on. Speed, another thing. Coverage, so how much do we really need to cover with our tests? We used to have coverage close to 100% for our critical components, and the more time we spent on that, we more realized that it's not necessarily a silver bullet. The level of abstraction, like whether it's unit test only or Selenium tests only, the access to unit tests, which means whether they are part of our code or part of a different library, or whether we have everything in our IDE when we change anything, and finally the effort spent. But all in all, we found that it's very difficult and it's dangerous to play with, to compromise on quality of the tests, which is determinism. So we definitely want all tests to be repeatable, reproducible, and maintainability, so the ease of maintenance. So how the situation looks like now. Obviously, the last slides I showed you were black, now it's white, so you may believe me, it's awesome. Unfortunately, it's not as awesome, but it's much brighter. So we started from teaching people and actually taking care of the people motivation. We didn't want anymore the red to become, to be the norm. We wanted green to be, again, the norm. And to do that, we really had to think about shades of red or shades of green. I mean, it's very naive to expect that a single lamp, green or red, can depict the state of the system, continuous integration, or the health of the software. Actually, we often laugh at our managers who would love to see all the projects in the company with one single lamp, green, red, yellow, and we ridicule them that it's insane, but sometimes with builds, we ended up with the same situation. We wanted to see just one red or one green for the whole complicated system. So we actually decided, okay, it's not 0 or 100%. There is always because we are very rarely at 100% of everything, but we are interested to know whether we are at 98% or maybe just at 60%. So that's how our pragmatic CI health was born. So we didn't want to just go to red or blue or green pill, but we introduced build tiers and various policies. So tier A1 builds, or in JIRA, those builds who have to be green as soon as any commit happens. So the developer who broke a build because of his commit, any build which was in tier A1, these builds were, for example, unit compilation, definitely, and normal unit tests, and they were really, really fast to get the results. All these builds had to be really fixed immediately, and the guy wasn't allowed really to go home. He was on the hook, we called him. He was like on the hook. Then we have a 2 tier, which we allowed to stay red for a couple of hours, but it still had to be fixed by someone. I mean, obviously, we know who committed the code by the end of the day. So it could mean in practice people working in the office till 11 p.m. maybe, but it could mean. In practice, I just saw maybe 2 or 3 times someone at 8 p.m. fixing something, because people very quickly learned that too risky changes, untested changes isn't the best idea to commit them after 3 p.m. basically. And A3 tier was the most time-consuming builds, like for example backward compatibility tests, or tests across various web browsers, or tests across various JDKs or operating systems, which had to be ready at the moment of the release to the production. But generally, they don't mean that the system is broken. There may be just some hole somewhere in some specific, for example, IE situation. There may be some button which doesn't work. So build tiers was one thing, and the second thing was making them obvious, the status of current builds. So in every room of each team or sub-team working on JIRA, we hang such screens where we had all the tiers and the current status. And obviously, everyone loved when this radiated with green. However, as you can see here, we have about 20 boxes, and one red doesn't mean that everything is red. It's no panic mode. We've run red. Maybe this build here is this A3 build. We can take care about it maybe tomorrow. So it was probably the best investment ever we have made in our company. It was like $800 for a TV, which has built-in web browser. It had even wireless. Here, the only cable we had to wire was the power. Unfortunately, it doesn't support wireless power yet. But that was the only thing we had to connect. And immediately, we could see that people felt uneasy when there was some red on the screen. I mean, previously they had it in their tray, in Mac or Windows, they had it in their IDE, but once it was radiated on the wall, it became more palpable and more important. We also trained all the people. I mean, we don't have many junior people on the team. I would say the average age experience would be like 10 plus years of professional experience, though we love to train each other. So obviously, a lot of people remember time when there was no JUnit still. So JUnit, 3, the old one was still for them a novelty. But there are better things which happened meanwhile, like Hamcrest assertions, like JUnit 4. So we had to spread this knowledge. We had to introduce library, which we called it Atlassian Selenium, which is an open source library, and I highly encourage you to try it out, which provided an extra level of abstraction on top of WebDriver to remove most of risk of races. We were converting and preaching that unit tests, including QUnit tests, are more important and more beneficial than functional tests, because functional tests in practice turned out to be costly to maintain. I mean, there is still some set. It's great to have some set of tests, but the ratio has to be really reasonable, like 2% versus 95%. Then we promoted more and more page objects, which are our wrappers for DSL-like driving of the tests. I highly encourage you, if you haven't used page objects, look at Google for it. You will find this. The idea is brilliantly simple, and it's really, really useful. And we run brown bugs, written blogs, code reviews, and so on. And then with the better awareness of people, we started taking care about the quality of the tests themselves. So first of all, what we noticed, the biggest problem which was dragging us down were so-called flaky tests. Flaky tests are tests which sometimes pass, sometimes fail, depending on, for example, timing conditions. There may be just some, typically there are just some races. And whenever you have experience in writing dynamic web apps with Ajax and so on, you will see that it's very easy to write a flaky test, the test which sometimes passes, sometimes fails. I would say that it's much easier to write such test than the correct one. So we added to Bamboo, obviously we use Bamboo as continuous integration server. We added the capability that Bamboo automatically detects for us flakiness. So the tests which are really not broken, but they are just incorrectly written. By a simple idea, Bamboo was rerunning each failed test again. And if it often, during the second attempt, it was successful. It meant that the test is just wrong. I mean, there is a bug probably in a product, but definitely the test needs the review. And then, of course, such tests were automatically quarantined, so we didn't want them to impact our state of redness versus greenness, so they were put into quarantine mode, like someone ill. And then we had a report about tests which at some moment require healing or killing. So after some time, the test was in quarantine. We had to decide, we had a limit, like up to 8 tests in quarantine. And at some moment, we had to decide whether to just remove this test because it doesn't bring value. And for example, it was red for last 2 weeks and the sky didn't fall in, so probably it's not necessary anymore. Or just to fix it. And it worked in practice really well. The other idea we had was that a lot of races and thus quality issues with tests were happening because of, could have been exposed earlier if we made our app responsive much slower. So we introduced a servlet filter, which, we were working in Java environment, but the same technology applies everywhere. Basically, we introduced an agent which was slowing down all the responses by, for example, 200 milliseconds or 100 milliseconds and so on. And thus, it automatically would reveal all the tests which were waiting for some fixed period of time instead of waiting for some event, right? Whenever you sleep or wait just fixed amount of time, it's broken. That's the first rule, right? It's broken because of 2 things. If you wait for 200 milliseconds, I swear that sooner or later it will be not enough because the system will be shutting, like starting up, or the backup will going on, and this 200 milliseconds on this given server won't be enough, and you will time out incorrectly. Or if you are waiting for 5 seconds, you are wasting 5 seconds. Time 20,000 times millions of builds, you are wasting an eternity, basically. So any timeout is just wrong, basically. Any fixed sleep. Timeouts are good, but fixed sleeps or fixed waits are wrong. And somehow we thought that this operation we call slow motion. We thought that this slow-mo will give us more benefit. Unfortunately, it revealed only like a handful of tests, which were in fact broken, and we fixed all of them. Then the other thing was Selenium 1. I mentioned that we started writing automated tests about 11 years ago. Then, of course, Selenium 1 didn't even exist then, but then it arrived. It was, of course, used as the new technology. We use all technologies which are showing, coming to the market, which are promising, of course. So Selenium 1, at some moment, someone said, okay, we are spending more time fixing Selenium 1 tests than actually writing new features. So it required one guy, 2 beers, and a bet. And a year ago, my colleague deleted all of Selenium tests. Just click delete, committed that, and went home, somewhat drunk. Otherwise, he wouldn't have probably tried it. Okay, and apparently everyone loved this idea and then wanted to be this guy who deleted this, but unfortunately the credit goes to this very single guy who made it. So did the sky fall in? Not really. Everything was quite fine. So after the red line is the moment when we deleted, it was like 1,000 tests. All of them like testing full application stack via web browser. They constituted 30 or 40% of our functional tests via web browser. So what really happened? Really nothing. I mean, we didn't observe any fluctuations in short term and in long term, any statistical difference about the quality of our product, and we measured the quality. I guess I speak Russian very poorly, but I did understand from the previous presentation that what matters in the real quality is measuring really like the support rate, customer satisfaction, and so on. And we measured exactly that. How often our support was contacted, how many bugs were raised by customers, and so on. So statistically, it didn't have any impact. And we saw immediately some benefits. Like we freed immediately a lot of build agents. So these 64 machines which I mentioned were much happier and they could serve different builds much faster. Morale of the team was boosted immediately. So people one day said, okay, today I won't be fixing any Selenium 1 tests. Why? Because they don't exist anymore. That was a very good idea. We saved, I think, like 3 gazillions of developer hours. Not 1 gazillion, but 2, 3 gazillions, and tons of money of infrastructure. And of course, it wasn't as simple as I pretend here. We conducted then, but afterwards, I still promise that was a brave, drunk guy who just deleted everything. I mean, somewhat drunk. Afterwards, we conducted the audit where we really analyzed all the tests which were gone. We wanted to allocate every test which was security related, and we wanted to rewrite it ideally JUnit, and if it wasn't possible in high-level tests like WebDriver 2. And it was a good exercise also for new hires who, with a good mentor, were doing that. I mean, new hires without a mentor would be the worst idea, but like 2 new guys plus 1 old veteran, there was an awesome team who they wrote like 100 tests out of 800 or 900, which we removed very quickly. So that was ditching of Selenium 1. I highly recommend it. Other thing was Flaky browser-based tests, which often, I mean, the problem we have is often our tests need to wait for an AJAX call, or the completion of the AJAX call, or a failure. And so far, people have been using various tricks around CSS, like adding special, before HR call is made, they are adding some special class, and then they are asserting whether they are waiting as long as this class exists, because on the success, this class is removed by the code. And the problem is that it's internally, first of all, it's dirty. When you write single-page apps with Backbone or Angular, it just hurts your eyes when you look at such code, when the model and view are basically interwoven. And the second thing is that it's still unsafe and flaky, because if you are in really bad luck, as we are all the time with the number of tests we run, it may happen that your CSS class hasn't been yet added, and already the AJAX call returned, and you don't know whether you are before or after this fact. So we actually introduced a very simple solution, which again, you can use the same idea without paying any dollar or penny. Just in our browser, in our JavaScript stuff, on completion of XHR, we just call some library which we developed called here is JIRA.trace, where we have some key triggering the event which just happened. And then, what is important, in tests, it does something, but in production, it's a no-op operation. It doesn't really do anything. And then on our tests in Java, in our WebDriver tests, we make a checkpoint, which guarantees that even if it's like the 5th time this XHR call is made, we are now have a snapshot of the status, and will be like the ticking from now. And then we are really wait for, so trace context wait for, basing on this snapshot till the moment where search completed event arrives. And the implementation is trivial. It's an array. So basically snapshot is an array, and wait for method is sleeping for like the very short amount of time, like 10 milliseconds and 1 millisecond, and checking whether in this array a new element called search completed was added. So that as trivial implementation as possible, and it solves all the flakiness issues around AJAX calls. Very simple, try it out. Other thing was speed. So always 3 aspects: people motivation, awareness, quality, and speed. And like 2 years ago or something, there was a long debate, a hot debate really on internet, whether in a complicated systems, builds which last 10 seconds are possible. And someone says that if the whole system is built in longer time than 10 seconds, sooner or later it will deteriorate in something unmaintainable. We were at that time we were at about 10 hours. So we said, okay, from 10 hours to 10 seconds. Oh, geez, we didn't believe that we can make 10 seconds, but we wanted to be as good as possible. So first we really, after the initial fixes, we went down to like an hour or something, and then the next idea was, can we halve it? Can we really decrease it by another 50%? So before we really attempted doing so, let's take a look on how our builds were run. So of course, we wanted to parallelize our builds to take advantage of multiple cores. So we split our tests, because tests, compilation and tests, into multiple parallel batches, and we hope that once we start them, then they will work, for example, be executed for, say, a couple of minutes, and then all of them more or less finish at the same time. Unfortunately, in practice it looks somewhat differently, because especially with normal continuous integration environment and with JUnit, for instance, or any other normal X unit, you have to create batches really rather manually by using categories or customized runners and so on. And some developer have to maintain, for example, using Java notations, which test goes to which batch to manually level the distribution. And sooner or later, it turned out that the batches became uneven. And obviously, the longest batch doesn't mean that there are the greatest number of tests. It just could mean that, for example, this machine has some problems with the performance due to any other activity going on. And in fact, it was even worse, because with the farm with CI servers, your building agents on the remote machines are not immediately ready, because they are often doing different stuff. So we had to wait for some stuff, and in practice, one of the longest waiting agent was this one, which had the longest batch to run. So this like fifth one from the top. So this was our reality. So we came with the idea, okay, let's cheat. And let's not distribute it manually, but let's allocate one of the agents and run a server on it, so that it dynamically, and on the server, all the unit tests will be queued, for all the system, and this test will hand it over to the remaining agents one by one. So that, if we have for example, if we have something which is calculated very quickly, then the agent which finishes such build will immediately ask for more. Okay? So the idea was to introduce something like that. We called it Hallelujah. It was an extra stuff built on Bamboo, and it in fact really helped us finish more or less in the same time, because if something was taking more time, actually the server wasn't serving handing over their more tests to this server. So more or less they were finishing at the same time, and you can see here that they are more or less finished. However, the problem was that as soon as, for example, one agent went mad, for instance, there was one out-of-memory problem, or the setup was broken, and a given test immediately meant redness, broken. Such agent could immediately drain the whole queue of tests, because it was just executing broken. So because it's a poisonous agent, really, because it could poison everything, and it wasn't very easy to detect such situation. Also, such approach isn't compliant to the architecture of typical CI server. So after a year and a half of using it, we are not so sure whether it's the right way to go, though we are still been using it and thinking about how to adjust our CI server, which we fortunately own and can drive the evolution, so that it can play a role in such situations. Okay, so before we go further, let me quote not from Edward Deming, because Edward Deming never has said that, and everyone who says that you can't manage what you can measure is deadly wrong, because actually the most important things you have to manage are those which you cannot measure, people. right? So this is a typical problem for managers. You cannot measure people, but you have to manage them. And that's the most important thing in your company. Or for example, customer faith in you. These are things which are not easily measurable. But nonetheless, because we are not talking about the people, but about the stuff, the hardware, the software, let's try to do put the problem differently, and let's try to first measure so that we can improve. Because without measuring after and before, it's difficult to compare, right? So here we started really measuring the stuff with the profilers in Java, with taking build statistics, using logs, using statsd, and we reported it to Graphite to see beautiful charts and really try to conclude what's going on. So let's take a look how the anatomy of build, which we thought should be typical, looks like. Of course, we have compilation, packaging. In Java, it would be like jar or var, compilation, and executing tests. But it's not everything. We have fetching dependencies. Those guys who know Maven knows what it means to fetch half of the internet. We have SCM update, of course. Somehow our source code has to arrive on the computer where the build goes on. And we have the time which need to pass for the agent to be available actually, to pick up our job. And finally, the agent has to publish results, for example, logs or unit test results in some central place. So it's also a time which we often forget about. And when we measured JIRA unit test build, so the simplest one, it looked like this. Compilation 7 minutes, packaging 0 minutes. I mean, it was like a couple of seconds. Executing tests 7 minutes. Publishing results 1 minute. Fetching dependencies 1.5 minutes. SCM update 2 minutes. Agent availability 10 minutes. It meant that even if we had shortened the time of testing from 7 minutes to 0, the whole build would be also still several minutes, so we wouldn't achieve the goal of halving the time, right? So sorry, it was very good to measure because we saw that we initially hoped that we'll just fix the tests. We saw, thanks to measuring, that it was impossible. So we started one by one attacking the problems. First thing, agent availability setup. The result was we have started builds, right? Lots of builds waiting for agents to build them in a queue. And it turned out, actually, that obviously, everyone who knows the rules of scheduling knows that the more time-consuming tasks we have, and the fixed amount of agents which can process them, the longer waiting time will be in general. So that's obvious. So one of the solutions to fix this problem was to make build faster, right? Then the waiting time would be shorter. But the second thing which we turned out is that we use S3, Elastic agents. Here it turned out that there is an NTPD problem, so time daemon configuration problem between our servers in Amazon cloud and S3 servers. It was a problem which only surfaced because we really was wondering why some files were for example, why an agent needs so much time to take a message from a queue. And once we applied the fix to NTPD problem, immediately the agent availability improved a few times, like 6 times. Second thing was SCM update and the checkout time. So we moved to Git like 2 years ago, and initially we performed shallow Git clones, right? We hoped that it would be enough, but it turned out that in fact it's still with a gigabyte repository, and the calculation stress we put on the server, on the Git server, is not negligible. And actually, Atlassian Stash, which is a Git server for enterprise, actually was dying just because JIRA agents, build agents, were attacking it with so many requests to Git shallow clone, and it's computationally quite intensive. So even Atlassian Stash had to add special queue not to kill the server. So we moved the problem from us to Git server, which wasn't the solution. So actually what we found out, let's trade some disk space for the performance. And we used an awesome Git feature, which we assumed, okay, let's keep on every agent a clone, deep clone of a given repository. We have to do it just once, and then we have to just update it, which is much faster than doing full Git clone or even Git shallow clone. And then for each build on this machine, we will be able to make a local clone, okay? So we have like two stages. First, we keep in sync our full clone on this server, and then for each build run on this machine, we have just a local clone, which is super fast, and in fact, is on Linux system is implemented with hard links, which means that we don't lose many, at all disk space. And in itself, improve the situation, the checkout time from 2 minutes to 5 seconds for a gigabyte repository. And here on this picture, you can see that this blue part used to be like 131, and now it was 8 seconds. Other thing was fetching dependencies. So because we were beaten like year and a half ago with a situation with when we built our production version, which went out to customers from accidentally from an agent where a bad Maven artifact was kept in its local Maven repository on this server. We decided from this moment to purge all the Atlassian artifacts before every build. And obviously it costed us because fetching dependencies from Maven had to be again done from our central Maven repository instead of using something from local cache. Additionally, we found out that there was a hardware problem with one of the Cisco, as far as it was Cisco, routers. We had to really dig very deeply to the stack of Cisco routers to find out that it was dropping packets, because Cisco didn't believe us that it's dropping packets. And it was great that we had engineers who would prove Cisco that they are wrong. And once they replaced this single hardware with exactly the same, it suddenly became not 90 seconds, but 10 seconds, so 9 times faster thanks to these things. Compilation, another thing. So we restructure our projects into multi-Maven 3 project because we heard Maven 3 is faster and we used to be on Maven 2. And we use the magic -T 1.5 C for core switch, which means the level of parallelism. For 4 cores, it means that Maven will run 6 threads at the same time, and that our research department, which means 2 developers trying by trial and error, proved to be the best ratio. With this approach, we made the compilation faster from like 7 times, from 7 minutes to 1 minute. Unit execution, somewhat similar. So first of all, we split them into 2 buckets, good and bad unit tests. Bad unit tests are those tests which set up too much. For example, they still set up an in-memory database, HSQL, or for example, they set up whole Spring context instead of just creating objects and injecting them manually with constructor-based injection. Because it's simple, new A, new B, and the parameter is A. And we used all the lightweight components, which times 20,000 weren't so lightweight anymore. So when we did it, 300 pull tests took 5 minutes, and 11,000 good unit tests took 1.5 minutes. So you can see, by the way, what good versus bad means here, right? Almost 4 times more good tests were 3 times faster than bad tests. And we ended up with the total decrease was from 7 minutes to 5 minutes because still pull tests were prevailing. From functional tests, definitely removal of Selenium 1 did help a lot. We used faster reset and restore mechanisms based on, we provided some backdoors to avoid, I would say, very safe but also slow restore and reset mechanisms. And instead in tests we could afford like a little bit hackish but 10, 20 times faster method of cleaning the state of database and the application of the caches. And also operations like logging in, any repetitive operations which were costly were replaced with appropriate REST calls. And all of this allowed us to make it much, much faster. So as you can see, in January 2013, we had here functional tests. Functional tests here means tests which don't use WebDriver. They are still using, they parse HTML, but they are not run in a browser. They use JWebUnit or HTML unit. So they used to be almost 50 minutes, even when distributed to so many machines. And now, after these changes gradually introduced, they were going down reasonably. And finally, publishing results. we had to talk to our application from CI to mark the places in the logs, the application logs, where new tests were running, so that then we could see them in continuous integration environment, logs per test. We didn't want to have a huge 1 gigabyte log. We wanted to have it split for each test. So it was costly. It was done using HTML unit, and now we rewritten it to REST API. It was just a REST call like this with the pre-authenticated REST call. And also, it turned out that Bamboo itself has some performance issues, which with keeping a lot of builds, like thousands of builds, big builds, and that's stuff which has been somewhat addressed and is still being addressed. So with these changes, we went from 1 minute to 30 seconds. And then we found some unexpected problems, like our servers started falling, became unstable, because suddenly we changed the bottleneck from I/O, all these weights on git clone and so on, to CPU. And it turns out that we were boiling CPUs really, and we had to decrease the number of physical, the agents on the physical machine to let this hardware really run normally, because like 200 degrees Celsius is not the right temperature for your processor. So after these changes, our builds look like this: compilation 1 minute, packaging 0 minutes, executing test 5 minutes, publishing 40 seconds, fetching dependencies 10 seconds, estimated 5 seconds, and availability of the agent about, pessimistically 3 minutes. And the summary of our test looked like this. So we were almost able to achieve 50%, okay? So we haven't met our goal of halving the time, but it was good enough to observe good trends. So the quality, the number of successful builds versus all builds went definitely up for unit tests and for functional tests as well. But it's still bad. We wanted CI feedback loop in a few minutes maximum, really. So we really realized that without splitting the code base further, and it's not that the JIRA is a big monolithic system. It already is composed of about 500 libraries done either internally or externally, and is shipped JIRA with about 100 plugins. It consists of plugins like Eclipse does, so it's difficult to say it's monolithic software. But it's still, we said, okay, we have to split it further. When we build JIRA, we don't need to, for example, recompile the kernel of Linux or Mac OS X. The same, it's probably time to move some older, more stable parts away and build them just when we really need it. Otherwise, just use jar. So we started splitting the code base, and we saw immediately a couple of the problems, especially around managing such more complicated releases and releasing itself. So what used to be a simple matter of just updating one number with a POM.xml file and releasing tons of children artifacts in the same repo, now wasn't as simple as that. Nonetheless, the first steps were made, and the JIOImporters plugin, which is responsible for all the imports in JIRA out of the box, have been successfully split 3.5 years ago with huge success, and new issue navigator as of JIRA 6.0 and issue view are now also a plugin, built completely differently, compiled just totally asynchronously to the remaining JIRA stuff, and tested also separately. But honestly, we are still escaping this hell, and it sucks us, really. I mean, it sucks us in. It's really sticky. Once you get to hell, it costs a lot to really go away, run away. So what the conclusions are of this story? So definitely the visibility and the problem awareness, being aware of the problem, and the visibility, I mean the current status, the metrics and so on, definitely help. It helped us to measure where we were, that it's already a hell. There is like the test costs, okay? The bigger the test bed is, the more difficult and costly it becomes. Before you improve something, start to measure it whenever possible. And we were shocked here that the core of our performance problems was not in the test run itself, the test execution itself, but in places like SCM checkout or waiting for the I/O and so on, or NTPD problems. That's not like writing an automated test is definitely not a one-off investment. I would say that's some people say Selenium, write once, maintain all the time, right? Or everywhere. It's not maybe as bad, but every test adds baggage. And performance is really, really important feature. So if you look back at what XP promised was, I would say that sad reality isn't exponential, but it's not constant. I would say that unfortunately the tests themselves also cost. So we cannot put them out of the question, because if the tests were free of charge, flattened curve could be possible. So if you are interested in this stuff, by the way, we are hiring in Gdańsk, or you can talk to me about this stuff also in detail in the hall afterwards. That's the images, the credits for images I'm obliged by law to show. And thank you, and any questions? Any questions? No questions, really? Oh, here they are. If I'm in a big corporation, what I have to do? No? Who implemented these changes? Okay, so the changes to the strategic changes around the infrastructure, like fixes to Bamboo itself or our logging mechanism and so on, were developed by a dedicated team, which I even was managing at that time, and that was a huge investment from a company. I would say that probably there are startups which would faster and cheaper build a new issue tracker from scratch if you compare the amount of hours and money invested into that. But I mean, we were the leaders, we could afford that, right? So we had a team of, I think, 4 people who have been for a year and a half now working on such stuff all the time. That's a full-time job. But regarding the tests themselves, maintaining good tests is the responsibility of everyone. So I mentioned brown bugs, code reviews, trainings, and so on. We rolled them out to all developers in working on JIRA. So because we didn't believe that someone will be cleaning up after someone else. So everyone had to be, as of that day, responsible for keeping tests in a better shape than to what they witnessed when they started working on. So the scout rule, right? So when they started doing something in some area, they saw, for example, oh, that test is, for example, too slow, written in WebDriver. So these guys were actually part of the definition of done was to rewrite everything which was possible to lower level test, lower level of abstraction, like unit test, and just remain, leave a couple of higher level tests using WebDriver to test, for example, integration, happy paths, and so on. Okay? Any other question? Okay. No? Yeah, so that's a very good question. Overlapping tests, definitely the more tests you have, especially on different level of abstraction, the more overlap we have. Theoretically, with the help of the coverage tool, there are open source ones like Covertura or Emma, commercial one from Atlassian called Clover. You could correlate and measure which tests are completely redundant because they also touch those lines of codes which are touched by other tests. However, in practice, we use here common sense because for developers it's much more natural to run just a subset on their local machines. They don't have 64 machines for every person. So it was practical for the developer to run just these tests, which because of the package naming convention or whatever, the knowledge, were considered to be most bound or tied, like most better aligned to the changes the given developer did. Okay, so it was easier for the developer not to run everything on his local machine, but just some subset. And when we start removing the tests, regardless of their the human friendliness to, I would say, regardless of how obvious it is whether some test touches something or not, then at some moment people are left blind and they would have to fully run everything all the time to make sure that everything is covered. So we have removed some tests, but it was rather, in fact, it ended up as a more manual process. Whenever someone was dealing with a big code base where there was, for example, 1,000 tests, people were spending hours really looking at what tests don't really bring value. And important thing is we were removing tons of tests. There are no sacred cows. Code is also removable. Really, it's a software. It can be deleted. There was some last question, and I will take the remaining at the whole. Okay.
Why putting monitors to the wall was best?
Okay, it was the. I mean, if we compare hundreds, if not thousands, of hours spent on other activities here, paying $800 for a monitor was definitely the cheapest one, and it brought immediately reasonable value for us, because immediately I saw it in the air that whenever something was read on the wall, not just on your computer, but on the wall, immediately people felt responsible to make it to restore the green situation. And also there was no, I mean, because it was so palpable, so visible, I mean, really overnight I saw immediate better attention from developers without the need of nudging them, asking them by managers. They were started really proactively handling such situation. So it changed the behavior.
How many people are watching at the same moment?
About 7-8 people per room watching single monitor, and people, obviously we don't, not everyone is responsible for everything. In JIRA we have now about 80 developers working on various components. So some teams are more interested in these builds, some in others, but all of them, I mean, this A1, A2, and A3, where all of people were watching those, plus teams were watching their specific builds. So the situations were somewhat different per team, but everyone was watching that. Okay, I have to finish now, and feel free to grab me at the corridor, at the hall. Thanks.